In this video, we're going to do a dependent samples t-test or paired sample t-test. Paired sample t-test can be used in a lot of arenas. It's basically when you're taking two separate, let's say, numbers and looking at a difference in them. It could be monetary, it could be time-based, it could be repetition, in terms of, let's say, shooting baskets. You can do one anytime that you're going to do a test retest. So if I'm going to look at something now and then I'm going to come back later and look at it later. So let's say let's go back to a simple one such as call center times and how long it takes someone to answer the phone and complete a call, or and then looking at it at a different date, doing the same exact test, shooting free throws now and shooting free throws later. There are tons and tons of different examples that are there and available. The standard formula for calculation T assumes there's no correlation between the groups. We're going to talk about correlation gently here. In our next module, you'll be looking at correlation a little deeper. This is a test where we're testing a group of participants twice. Most times is a pre-test and a post-test comparison. Assumes that the relationship or correlation exists between the scores and a person's score, and the post-test is partially dependent on his or her pre-test score. Basically saying that there's two tests, you do the same test twice, you're looking at, there's going to be always going to be a relationship because it's going to be basically the same thing, and you're looking at the basic score. So it could be time, could be money, could be a number of times something is done. It can be just about anything in that realm. So we're going to get right into an example. In this example, we are examining the hours slept and caffeine. The test is performed on 10 participants where should be 5 participants, where one group drinks caffeine and the other one does not. Okay, so we have 5 participants. You see the left, caffeine, and you see the right, no caffeine. Okay, this is a very small sample size, being 5. Just in general viewing of this, we can look and we can say, okay, the people with caffeine got more hours of sleep. 9, 10, 8, 9 are better than 6, 5, 4, 7, and 5. But it doesn't really narrow it down to an exact mean. In this case, it is so important that you understand now what the most important factors are, what you're really looking at, and then where do you really need to look to find your conclusion. Okay? In this case, in a paired sample t-test, it's truly in the mean. You'll see here on the left it says caffeine and no caffeine. Those are your two variables. The mean is the most important part. So we can look and we know that 9.20 hours of sleep is better than 5.40 sleep. 5.40 sleep. Okay. Next box over is the N is the number of participants, which we had 5, and then our standard deviation tells us the dispersion from the mean. The important fact in the output, in this output is the mean. The output tells us that the participants who did not consume caffeine slept more hours. You look at the mean, it tells a story. You got to figure out the story in whatever you're doing. Now we need to touch base on correlation because that's the second box. Okay, it's not going to be in depth. It's just going to be a glossing over it just enough so you can get through this output that you have to work on in class. Okay, correlation is all about relationships. Write that down, memorize it. Correlation is relationship. There's 2 places. Scatter plots you can look at, and we basically are dealing with the Pearson correlation coefficient. Okay, that's the name of it. The scatter plot gives you a visual representation of the relationship. What is a correlation? It's a way of measuring the extent to which 2 variables are related. It measures the pattern of responses across variables. We need to see whether one variable increases or the other one variable increases, the other variable increases or decreases or stays the same. This can be done by calculating the covariance. we look at how much each score deviates from the mean. If both variables deviate from the mean the same amount, they are likely to be related. Okay, so now this is a scatter plot. You see how the dots, that's all the answers. They're placed in this scatter plot, and you see that there's a line in the middle. That little dotted line is called the best fit line. There's no rhyme or reason to this. There is no relationship in actual answers. Okay? This is a very small relationship or none. Okay, our next slide here gives us a positive relationship. You see how it goes up? So let's say this is age, and I don't know what the other side is, so we're going to make it up. This is age and number of sit-ups. Okay, you'll see on the bottom line the age, it goes from 10 to 90, and over here it goes from 10 to 80. So a positive relationship, both answers go up. So as age goes up, the number of sit-ups goes up. So you see they're, say they're 18, 19 years old, they're doing about 15. Now as the age goes up, now at the age of 50, they're doing 30 to 40. And when they get up to the age 80, this stud over here is doing almost 80 sit-ups. So both of them in a positive relationship, both of the answers go up. The conclusion to this would be as age increases, amount of sit-ups increase. The next one up is a negative relationship. You see how the best fit line, that dotted line, goes in a different direction. If I'm going to use the same scenario, age on the bottom, and I've got a number of sit-ups, I flip the script now. As age goes up, the amount of sit-ups completed go down. So one goes up and one goes down. Negative, one goes up, one variable goes up, the other one goes down. In a positive relationship, both go up. No relationship, of course, is no relationship. So I have an example here. Anxiety and exam performance. There was 103 students. Time spent revising, exam performance, exam anxiety, and gender. Okay. Here's what SPSS looks like. Here is the output. Okay. This is called a matrix, and it's real important for you to understand. It's just like a round-robin tournament. You'll see where exam performance here, okay, and exam performance here come out to 1. That's a perfect correlation, okay? Exam performance and exam anxiety, you see Pearson correlation. That's our correlation number on R value is negative 0.441. It is significant, and this is the 103 we talked about. Okay, you'll see that this one and this one are the same because exam anxiety, exam performance, exam anxiety. So they're going to come out the same. Here's another way of looking at it. So here is your output box for your correlations for the caffeine and no caffeine test. Okay, so we have the N, which is our number of participants, okay? And then we have a correlation, okay? It's negative 0.235. And you'll see I put it kind of on this number line. So I want to go with this number line real quick. Negative 1 and positive 1 are both perfect correlations, okay? You can't do any better than negative 1 or positive 1. Go back to when you were in beginning math, back when you were a kid, and they give you a number line. They said 0 and negative was less than positive. In this case, that 0 is your center point. That is where you have no correlation at all, okay? And each of these go in a direction, okay? This is positive on this side, and this is negative on this side. How do we know it's negative? Because there's a negative sign right there. If there's no negative sign there, then it's a positive correlation. But this negative 235, if I was to put in a negative 2.235 on this side, on the positive side, they are actually equal. There's no difference. It is the difference away from 0. They're negatively correlated and positively correlated. So there's no difference between a negative 0.235 and a positive 2.235. It's all in how the participants answered. I'm going to go into that a little deeper later. The big thing you have to remember is this number of 2. Okay, this is a This is a slightly negative correlation. If it was on the positive side, it would be a slight positive correlation. 0.2, slight. 0.5, moderate. Anything above 0.7 is high. So it's always going to give you, okay, a strength, and it's either positive or negative. So in this case, in this sentence here, for a conclusion, the Pearson moment correlation is slightly negative, a slightly negative correlation at R. R is your correlation letter, equals negative 0.235, and is non-significant at P is greater than 0.05. So you see the significance level is way higher than 0.05. So it is non-significant, and you write it as P is greater than 0.05. This is the last box, okay? And you'll see that a lot of this is repetition for some of the other ones, unless this is your first one. You'll have a t-value, you have a df, and you'll have a significance. We don't so much stress about this paired standard deviation, but this is a good note. The mean difference is the difference between the mean of caffeine and the mean of no caffeine. So if you go back, there's a negative 3.80 difference in the paired sample from caffeine to no caffeine. You'll see that the t-value is negative 4.42, which is basically the same thing as 0.012, which is below 0.05, so you'd write it as P is less than 0.05. There were 4 degrees of freedom because you had 1 to vary. It was 5 participants minus 1 equaling 4. Okay? You will have an example that you will be performing, and it will be, and this is the one you'll be working on. Here are the scores for a volleyball, and you'll find this in there, and you need to pull out. You'll make a decision on whether the preseason or the postseason was better in volleyball serves.